Welcome. My name is Michael Tawonga Kamanga, your chemistry teacher from 1, and I'm here to take you separation of mixtures. We have looked at so many processes. We have looked at so many physical methods for separation of mixtures, and one of them is sieving. We said in sieving, we mainly focus on solid to solid type of mixtures, and these solid to solid mixtures can be both homogeneous and heterogeneous. But in this lesson, we'll focus much on using magnets. So separation of mixtures using magnets. So again, we are targeting mixtures which are solid in nature. The mixtures which are solid in nature. Now, mixtures are very, very important. The idea of mixtures helps us to understand the characteristics of mixtures, the types of mixtures, the nature of mixtures, and this, by the end of the day, will assist us in knowing them better. And when we want to separate them, we should use the right physical method. So please be attentive as I take you through this lesson. Now, as I already said that here we are going to use magnetic separation. Magnetic separation, meaning to say we'll be targeting those mixtures which have components which are magnetic in nature. So for this method to work, one of the components of the mixture should be magnetic, should be a magnetic material, while the other should be a non-magnetic material. Otherwise, the method cannot work. So whether it is magnetic, the one which is magnetic, then the magnets will be able to be attracted. Those materials will be attracted to the magnet, and hence the method will work. However, allow me to take you back by describing solid to solid mixtures. So I should take you through the solid to solid mixtures as one way of linking our today's method to the previous knowledge which we have. So our prerequisite knowledge is on mixtures, types of mixtures, more especially solid to solid mixtures. So quickly, let me take you through that. Well, a solid to solid mixture is just a combination of two or more solid substances mixed together, and in these mixtures, each component retains its physical properties and can often be physically separated. So solid to solid mixtures can vary widely in their composition and can be homogeneous or heterogeneous, depending on how uniformly the components are distributed. So in a solid to solid type of a mixture, in this mixture, we only need components which are solid in nature. They can be two or more. Once they come together, they will physically combine and form a mixture which is known as a solid to solid mixture. So this mixture, the components, they will be joined, yes. They will be combined, yes. But they will be combined they will combine physically and not chemically. No wonder if we want to separate them, we are supposed to use chemical methods rather physical methods. So we have to work on them physically. We have to separate them physically. So properties can often be physically separated, and then solid to solid mixtures can vary widely in their composition and can be homogeneous or heterogeneous, depending on how uniformly the components are distributed. Now, on the examples of solid to solid mixtures, we have alloys. Alloys, they are examples of solid to solid mixtures. What type? Homogeneous. Because in alloys, they are homogeneous and you cannot tell that this is component A and this is component B. So yes, alloys, they are a mixture. They are solid to solid mixtures where the components are uniformly distributed. So there's a uniform composition. The uniform composition. So alloys, on alloys, and one example of an alloy is bronze. Bronze is just a mixture of copper and tin. Copper and tin, these are metals. Copper is solid and tin is also a solid. So if you combine them, you form a solid to solid type of a mixture which is known as bronze. And bronze is an example of an alloy. Can you give me other examples of alloys as the examples of homogeneous solid to solid mixtures? Quickly, can you type something in the comment section? Okay, so as you can see, that one is our bronze. So this is bronze, which is a mixture of copper and tin. So this is bronze, and you cannot tell that this is copper and this is tin. No, this is just a uniform composition. So these rods, they're representing bronze. And as you can see, it is very attractive. It is very attractive. And one of the uses of alloys, it is used in the cosmetics and jewelries. As you can see here, bronze. Bronze, it is very, very attractive. So it can be used in jewelries. Then another example of an alloy is brass. Brass is a mixture of copper and zinc. It is a mixture of copper and zinc. As you can see, you cannot tell that this is zinc, this is copper, because copper is a metal, zinc is a metal as well. So if they are blended together, they form an alloy which is known as brass. So it is homogeneous. There's uniform composition. So here there's uniform composition of copper and zinc. So this is brass. So this indeed fits to be an example of a solid to solid mixture which is homogeneous. So homogeneous, there's uniform composition of the components of the mixture. You cannot tell that this is component A or this is component B. In brass, you cannot tell that this is copper and this is zinc. So yes, for sure, this is a solid to solid mixture which is homogeneous in nature. Then another example of an alloy is the stainless steel. Stainless steel. So this stainless steel, it is a mixture of iron, chromium, and nickel. Iron, chromium, and nickel. There are three. And again, if you take a closer look to this chromium, one rod or one bar of chromium, another stainless steel, you cannot tell that this is iron, this is chromium, and this is nickel. No, because there's a uniform composition. Uniform composition. So again, this is our homogeneous mixture, which has uniform composition. You cannot know that this is iron, this is chromium, this is nickel. No, there's an even distribution. There's a uniform composition of the three components of stainless steel. And stainless steel is very, very important. It is widely used domestically. And you talk of cooking utensils, you talk of pots, you talk of plates, cups, which are metallic, spoons, forks, they're made up of stainless steel. So this is widely used domestically in our homes. It is very, very important. And stainless steel is a good conductor of heat and electricity. No wonder it is used in cooking utensils, in pots, in pans, and so on and so forth. Why? Because it is a good conductor of both heat and electricity. Then granite. You talk of granite. This is composed of different minerals including quartz, feldspar, mica, each visible and distinguishable. Aha. Now in granite, each component of granite, whether it is quartz, feldspar, mica, they are visible and distinguishable. So, granite, is it homogeneous or heterogeneous? If each component is visible and distinguishable, where can we put it? Homogeneous or heterogeneous? Obviously, heterogeneous. Why heterogeneous? Because the components forming granite are visible and distinguishable. So there's non-uniform composition. You can be able to tell that this is quartz, this is feldspar, this is mica, and this is and so on and so forth in granite. The same with soil, which is a mixture of organic matter, minerals, gases, liquids, and various organisms. The same with soil. Okay, so in solid to solid mixtures, therefore, they can be homogeneous and heterogeneous. Homogeneous, the components are not visible and they are non-distinguishable. In heterogeneous, the components of the solid to solid mixture, they are visible and distinguishable. Meaning to say you can see with your eyes that this is component A, this is component B. We have seen that in granite, granite is heterogeneous, while alloys, they are homogeneous. Can you give me examples of alloys? Yes, we talked about brass and bronze. So these are homogeneous solid to solid mixtures. Okay, quickly, what are the characteristics of solid to solid mixtures? These solid to solid mixtures, what are their characteristics? How can we know that this is a solid to solid mixture? They have retained properties They have a variety in composition and even their separation techniques. So these are eye openers of knowing that this is a solid to solid mixture. On retained properties, since the mixtures, the components of mixtures, they join physically and not chemically. If we are to separate them, they will retain their original properties. You talk of color, hardness, melting point, odor, and so on and so forth. So the chemical, rather the properties, more especially physical properties, they are maintained, they are retained rather. Variety in composition. The composition of soil-to-soil mixtures can vary widely, leading to different physical and chemical properties. So the composition of solid-to-soil mixtures can vary widely, yes, leading to different physical and chemical properties. So indeed, they vary in terms of composition. On separation techniques, we employ physical methods such as sieving, magnetic separation, flotation, or mechanical sorting can be used to separate the components. So yeah, we can use these separation techniques. So the separation techniques are the physical separation methods. They can be sieving, magnetic separation, flotation, and even mechanical sorting. But in this lesson, remember we are focusing on magnetic separation. Magnetic separation. So let us see how it is done. The magnetic separation. So the general idea of solid-to-solid mixtures is very fundamental. Okay, so in the separation of mixtures by using magnets uh, is known as magnetic separation. So we are using the magnets. We are using the magnets. No wonder it is known as magnetic separation. So this is just a process used to isolate magnetic materials from non-magnetic materials in a mixture. Because naturally, some substances or some materials, they are magnetic, while some, they are non-magnetic. So those which are magnetic, they are attracted to a magnet. Which are non-magnetic, they are no longer attracted to a magnet. Okay, so meaning to say, in your solid-to-solid mixture, you should have a magnetic material for this process to work, because it uses magnets. No wonder it is called magnetic separation. So it uses magnets. So you need a magnetic material to be one of the components of your mixture. So let us go through the description of magnetic separation as a process of separating solid to solid mixtures. Now, on the description, first of all, we'll start with the purpose. Magnetic separation is used to separate magnetic materials from non-magnetic materials in a mixture. It is particularly effective for sorting iron-containing ferromagnetic substances from non-ferrous materials. So first of all, the purpose is that this process of magnetic separation is used to separate magnetic materials from non-magnetic materials in a mixture. So please take note of that. And what is the process, the overall process? So there is identification of magnetic components. First of all, you are supposed to identify if there is a magnetic component. So identify the components of the mixture that are magnetic, e.g. iron, nickel, and cobalt. These are magnetic materials naturally. So you need to identify magnetic components in your mixture. From there, application of magnetic field. After you identify, you have to apply a magnetic field. How? You expose the mixture to a magnetic field using a magnet or magnetic separator. By doing so, you are applying a magnetic field to the magnetic components which you have identified in your mixture. So there now, attraction and separation. So the magnetic materials are attracted to the magnet and separated from the rest of the mixture. Because naturally, I've said a magnetic material will be attracted to a magnet. That is why it is very, very important to identify if you have magnetic components in your mixture. Because if you apply the magnetic field, the next thing is those magnetic materials will be attracted to the magnet. Then from there, collection. The separated magnetic materials are collected and the non-magnetic materials remain behind. See, now you have separated your mixture. What are the tools used? Obviously, it is magnetic separation, so you need a magnet. It could be a simple bar magnet or a more complex electromagnet can be used as well. So a simple bar magnet or a more complex electromagnet can be used depending on the application. As you can see, this is just a simple magnet. So you need a magnet since the process is magnetic separation. This magnet will provide an electromagnetic field. It will provide a magnetic field where the magnetic materials will be attracted. You can also need a magnetic separator, and this one is used in the industry. In this industry, so industrial magnetic separators such as drum magnets or belt magnets are used for large-scale separation process. So these magnetic separators they are used in the industry. Examples of magnetic separation in recycling industry, in mining. In recycling industry, magnetic separation is used to remove ferrous metals from non-ferrous metals and other materials in recycling processes. In mining, magnetic separators are used to extract valuable minerals such as magnetite from ore. So it is used to extract valuable minerals such as magnetite from ore. Then in food industry, magnets remove iron contaminants from food products, ensuring product safety and quality. Because if you have magnetic contaminants in food, this can endanger our health. Then it can also be used in environmental cleanup. Magnets can be used to remove iron particles from soil or water, aiding in environmental remediation. Magnetic separation is a versatile and effective method for separating mixtures with magnetic components, and its ability to quickly and efficiently separate materials based on magnetic properties makes it invaluable in many industrial and environmental applications in many industrial and environmental applications. So yes, it can be used in food industry and in environmental cleanup. Okay, so quickly let us go through the video illustrating magnetic separation. As a summary, let us see how that works. So those are iron filings, which are magnetic in nature. Then we have zinc granules, which are non-magnetic in nature. Zinc granules, they are non-magnetic in nature. So we have our magnet, which will be used. So the two solids are mixed, forming a solid-to-solid mixture. So you move a bar magnet in the mixture, and then the iron particles will be attracted to the magnet. Why? Because they are magnetic particles, as you can see. So the zinc granules are not attracted to the magnet simply because they are non-magnetic. So you can prefer to use a horseshoe magnet because it is a little bit faster than a bar magnet. So using this technique, we can easily separate. As you can see, we have our iron filings separated from the zinc granules. Yeah, so quickly, the advantages of magnetic separation: efficiency. So quickly separates magnetic materials from non-magnetic ones. It is also cost effective, relatively low cost compared to other separation methods. Non-destructive, does not alter the chemical or physical properties of the components. It is scalable. It can be used for small-scale laboratory applications or large-scale industrial processes. However, it has its own limitations. It is limited to magnetic materials only, and even the magnetic field strength, it requires a very strong magnetic field. Then the particle size: small or fine particles may be difficult to separate due to reduced magnetic susceptibility. So these are some of the limitations. And on the applications, recycling and waste management, mining and mineral processing, and again in the chemical industry. You can apply this magnetic separation. So in chemical industry, it is used in purification of chemicals and separation of catalysts as well. Okay, so we have looked at the magnetic separation as a process of separating solid to solid mixtures. Now, let us do the following activity. Please provide your answers in the comment section and compare with my suggested answers in the description. Okay, question number 1. What is the magnetic separation used for? How does magnetic separation work? And what type of materials can be used in separating magnetic separation? In using magnetic separation? What are the advantages of magnetic separation? And what are the limitations of magnetic separation? And how is magnetic separation used in recycling? Well, if you have questions, you can use the WhatsApp number. This is our WhatsApp number. And you can also use help@xulendo.org or visit Xulendo online. That is xulendo.org. Please, in today's class, I've used the following resources: Excel and Succeed Junior Chemistry Book 1, Achievers in Chemistry Book 1, Django Chemistry Book 1, and Samuel Kalea Chemistry Book 1. For the photos, these are the links which I've used for the photos. So you can feel free to visit the links. Well, until we meet again for the next lesson, bye-bye.